Good to be back. Good to see you guys again, and good to see another YUI conference. So today is talking about touch and a little bit just of a survey of touch, a tour of touch, seeing what's out there, what's coming, and hopefully this leads in well to the other talks in the rest of the conference. There's 2 more touch talks coming up, so hopefully this will sort of whet your appetite and get you thinking, and they can deep dive a little bit more. So in doing all the research and reading around and thinking through what I had previously thought about touch, and I had a chance this summer to work at a little stealth startup and play with the touch and get to use YUI a little bit. I kind of broke this talk down into sort of 4 different pieces. Sort of touch as input, touch as intent, how to implement touch, and...
Did you start your screen recording?
Yes, we're recording. And then an opportunity to invent. So I'm a sucker for alliteration. Like I said, there's more talks coming up. Mark's going to be talking about fingertips, lessons learned from building a touch-based experience, working on fantasy football. And then Satyen tomorrow talking about a phone, a tablet, and a laptop walk into a bar. YUI's approach to mobile web development. And if you've been looking at some of the touch stuff and the gesture stuff in YUI 3, he'll be talking a lot about the philosophy there and what's in there. So I'm looking forward to both of those. One right after this one, the next one tomorrow. So touch is input. There's a lot of categories of input, sort of in the big world of input beyond the browser and including the browser. There's different modes of input, mechanical input, voice and audio and video input. And this is sort of pulled from a Wikipedia page. So they're talking about everything. They're talking about light pens and video screens, game controllers, and everything. And as we start to branch beyond, I think, keyboard and mouse, we're not going to get all the way to those things right away, but it's sort of interesting to think about how it all fits together. So there's different modes. We're mainly in sort of a mechanical mode in our world, of course. Discrete versus continuous. If it's a motion, if it's a gesture, or if it's just a tap or a key press. Depending on the type of software or the type of interface in general, there can be different degrees of freedom. Generally, that means 2-dimensional or 3-dimensional. Generally, you see 3-dimensional in things like CAD or in some sort of 3D modeling or animation programs. But we don't worry about that a whole lot. And then talking about pointing devices specifically, they're sort of the direct or indirect. And I think that's one of the things that a lot of people find so compelling about modern smartphones and tablets and touch devices, is that instead of being an indirect player or an indirect input, by moving a mouse over here and seeing a cursor over here, it's direct input. You touch what you want. The interface is the content, and it's all right there. And then another distinction is sort of absolute versus relative, and really that just means the coordinate space. So absolute is sort of a touch screen where you're absolutely touching where you're touching, whereas with the mouse, it's more relative. You can pick it up and move it and sort of reset. So those are some of sort of the broad categories of input. Want to do a little quick quiz or history. Anybody know this reference from 1875? I tipped Doug off before in the hallway, but I think he knew it actually. Sorry. Anybody? So Christopher Scrolls is responsible for the QWERTY keyboard and rearranging the keys so that you had to type slower. So he was actually trying to degrade input. You were typing so fast that the mechanical arms were getting caught up in common words if the keys were close together. So they mashed all the keys up into a configuration that only made sense because it made you type slower. And so the keys were coming from different areas. So I think that was probably the last time that we were trying to reduce the fidelity of input for users. More people might know this one. Anybody? The first mouse. Engelbert's idea, and English did the prototype. What about 1971? Dr. Hurst, the first touch sensor. And here it was really like a light wall. It wasn't a screen in the same sense, but the first person to really use sensing where people were in position as an input. Does anybody remember this device? 1995. It's a mouse. It was the first mouse with a scroll wheel. And now, it'd be really frustrating to not have a scroll wheel as we're browsing web pages and looking through file systems. A lot of us live on a keyboard, but still, the mouse wheel is a pretty nice thing to have. Interestingly about that, though, is that wheel events, well, I guess the question here is, when did wheel events sort of get codified into the DOM? When did those become events that we could program against and move against? You guys are sleepy after lunch, so I'll just keep giving you the answers. DOM 3. And so prior to that, that happened pretty quick. That's 6-7 years after 95, the first sort of DOM stuff, DOM 3 stuff. But then, and that's really the last, I think, addition to a DOM spec that gave us sort of more control over inputs. What about this number? This is a daily number. You're laughing. You know it? No? This is the number of touch-enabled devices, mainly smartphones, that are sold every day. So these are the number of touch devices that are entering the market every single day. This is a couple months ago. This is from Luke Grabowski's math. So give or take, probably quite a few more at this point. But that's really sort of what's happening with the new sort of explosion of interest and capability in all this stuff. So touch is really compelling because it's direct and absolute. It can be discrete or continuous, a high degree of freedom, a really kind of promising new way to interact with content, interact with interfaces. So it's not just touchscreens. Apple's got their mice that give you a lot of different ways to interact. You can do your swiping right on there and some zooming and scrolling in different axes now. They've got their pad, or they named it strangely, but Magic Trackpad. Not sure how magic it is, but still bringing those same sort of touch events to a different surface. But still is another way to interact, at least with the operating system. So click, scroll, swipe, rotate, things like that. Androids had a lot of different devices. This is the first 100, which is cool. I mean, it means there's more devices solving more problems in more people's hands. Also more variety, so not just 4 or 5 browsers, but lots of different devices, lots of different software on top of the native software here. But still, it sort of boils down to the big mobile players that are the most interesting when we're talking about touch, especially in a web context, especially at a YUI conference. So you've got iOS, you've got WebOS, BlackBerry, Android, and Windows Phone 7. Seem to be on a bad streak of naming things these days. But so anyway, so let's look at a little more detail. So these are those different platforms. I left BlackBerry off because a lot of their stuff isn't exposed up through APIs that we can really interact with. And even all these other ones aren't either. We'll talk about that a little bit. So we've seen a lot of really sort of common idioms, common interactions emerge already. Tap, double tap, fling or flick, drag, and the other ones you see up there. But you can see that even though people are supporting the same sort of core events or core concepts, there's already some divergence. They're not named the same. They don't always work the same. Sometimes there's more modifiers. So in the case of WebOS, you can drag in a couple different ways. You can pick something and then move it, or you can just swipe things around. And so as we're thinking about programming against this stuff, now and in the future, there's a lot of stuff to normalize, and of course that's a YUI strength and a strength of front-end engineers in general, is figuring out how to tame all this stuff. So again, thanks to Luke W. for all this, a lot of this research. He's done a good job gathering it up. So lukew.com/touch has this and this chart, or the data that went into this chart, and a lot of other stuff. It's a good resource. It's also a good place to point your designers if they're going to start thinking about this. He's got a lot of stencil kits and other sort of discussion about these things. All right, the last quiz, I think. This is, 8 days ago? Does anybody know what happened 8 days ago? Yeah. 8 days ago, the W3C launched a new working group to look at this exact topic. So Eric tried to get me to give this talk this summer, and I'm glad I said no for so long, because now it's even more relevant right now. So the W3C is working on this. They're working on touch. They're working on multi-touch. They're trying to broaden the conversation and look at pen devices and other things, tablets and so forth. And they're also trying to look at the difference between sort of the physical actions that make up these interactions and sort of the higher level, sort of what it means. So they're just getting started. They've had 4 tweets. I think they had a lot of followers. I think last night when I clicked, I was 50-something. So they're up to 67 followers as of an hour ago. But it's a great, if you care about this stuff, if you're interested in this stuff, it's happening right now, and they're fast-tracking it. And we'll talk about their schedule here in a second. But first, let's sort of look at their charter. It's more than a Twitter page. They have an official charter. They've got a team. So they've recognized that browsers and devices are making increasing use of this sort of touch-sensitive inputs. And the cool thing for us is it enables web developers to build more intuitive and sophisticated applications that fit naturally with the device being used. So there's a couple things in there. Most interesting to me is that it fits naturally with the device that's being used. So Eric did a great job years ago helping articulate what we're trying to do in terms of interface design by saying we're moving from the implementation model to the mental model. With modern JavaScript and DOM, we're finally able to remove the nitty-gritty details of how everything works and create interfaces in the browser that behave much more like users think. So the classic example is instead of checking 20 checkboxes and then use a submit form or a select element to choose which folder to put them in, now you drag your messages to the folder you want to put them in. So that was the move from implementation model to mental model. That will always continue. But now we also have an opportunity to sort of fit our interfaces to the device and the use case sort of for that device. So I thought that was a good correlation to what he's been talking about for a long time. And I liked that the W3C sort of pointed that out. So they're really breaking out their deliverables into 2 layers. Low-level physical events. What is a touch? How do you think about pressure? How do you think about velocity? How do you think about multiple touches? And then high-level things, like what do those things represent? Hopefully, as we're developing against these APIs in the future, we're not going to be worried about the actual physical events that's causing these. We're going to spend most of our time designing against the high-level representation. What does it mean when I'm moving something over or pinching? The fact that I'm pinching and zooming is more interesting than the fact that I'm putting 2 fingers on these 2 areas or these hot spots or whatever the case may be. So like I said, they're moving quickly. I know it's small there at the bottom, but they're aiming to have a first-pass working draft in February and a candidate recommendation sort of by the end of the year. So we'll see how they do against those goals. They'll probably do better if some people give them some input. So interesting thing to sort of pay attention to. So touch is input. It's also intent. And it's a physical manifestation of intent. So I want to see more. The pinch is one of the more compelling and most replicated sort of interactions in a multi-touch world. So I want to see more of a view at once. So the user moves 2 fingers towards each other in a pinching gesture with the conventional meaning of zoom out. So let's parse that a little bit. So it's not really fingers, it's touches. And the rationale is that I want to see more of something. So that's a slight rephrasing there. We're getting rid of the low-level physical, the fact that it's a finger, and we're just saying it's touches. And you can really break it out into sort of 4 components. What's happening, what the gesture is, what the purpose is, and what the motivation is. And so the physical thing is when the user moves 2 touches towards each other. The gesture that equals is a pinching gesture. It has a conventional meaning, and it has an intention that the user is working towards. So that's how, as I read through sort of the developer docs for iOS and WebOS and a little bit from Microsoft and the others, there's a lot of divergence already in their nomenclature, how they're thinking about it, how they're exposing their APIs. This is the way the W3C broke it out, and it's a fairly good middle ground between what exists in the literature so far. There's also a note that as you're starting to have these APIs and these objects, that there's some sort of metadata that could be associated with them. So they're trying to step up a layer beyond the individual device and leave some room in the language for a notion of metadata. And one of their examples is, which pen is it or which pad is it, and maybe that has an impact. In the iOS world, they begin a phase moves, a phase ends as you're doing these different things. And again, with iOS, they expose a lot of these things in a lot of convenience methods that say, pinch is happening. But especially in the native environment, you can define sort of an unlimited amount of gestures beyond those 8 that we looked at, that can be specific to your application. And they sort of break the API out like this. Something's possible, you're registering it, you can do this, be on the lookout for it. Something began, something ended, maybe it failed, maybe it completed, maybe it was canceled. So we're starting to see, as I was trying to find common ground in all these different sort of specs, it doesn't totally exist yet, but this is sort of one of the more granular ones that's out there right now. I think Satyen tomorrow will be talking a little bit about how they're breaking it out in YUI specifically, and I'll touch on that work that's already been done. So what's in YUI today? How do you implement touch? It's embarrassing that it's about me, but this is a video we did at YUI a couple years ago, and one thing I said is we don't know what's around the corner, so we need a solid foundation to prepare for it. And I was on Twitter last night, somebody wrote that, so I grabbed the screenshot. And I think it's really interesting because YUI is exactly that solid foundation that we need for the future. And the work that's already been done, starting last year at YUI Conf 2009, Luke's Events Evolve talk, really laid the foundation for the stuff that's happening now with touch. So even though we don't know exactly what's happening, touch was out then, but even though we don't know exactly what's coming, having smart code, having a lot of contributors, putting things in there, get us to sort of WT or FTW. So specifically, sort of synthetic events. Have people done anything with synthetic events in YUI? A handful of people. So it's a way to define new events beyond sort of what the DOM offers. And one of the reasons I mentioned the scroll wheel or the wheel events is that's really sort of the last introduction to the DOM of, or one of the last main ones of types of new events. And so everything else after that, we're going to have to sort of do ourselves until they catch up to some extent. So synthetic events are like custom events, except in that you can label these interesting moments, but you're doing it at the page level instead of at the sort of component level. You're just sort of adding these things to the DOM, and then you can interact with them like you would any other event. So you can define these events and then do anything else we would do to any other event in all these event-driven things we're building. So props to YUI and props to Luke on getting all that stuff in there. It makes a lot of things possible. So there's more stuff in there. In particular, down here at the bottom on your left are the event touch modules of event. And on the right there are the event gestures, where we're starting to take those low-level things and build them up into more common gestures, sort of the meaning, not the physical pieces. So I want to walk through those a little bit. So event touch is I don't think we really interact with that a lot directly, but it adds to the facade of the events that are in there and normalizes some of the stuff that's going on. So it's a way to track the touches, what's changing, where they're targeted in sort of the standard facade that's in there. So that one is required by everything else you'll see and everything else that we'll all build. And I should also say that as I get things wrong here, especially that back corner should wave and clarify for the record. So far, so good? All right. So low levels touch, but then the more interesting things are these gestures. Like, so you take all those physical things, and now we're getting closer to intent. So on touch devices, this gesture move start event fires in response to a single finger touch start. But it's also normalized that we can't just build things for touch. We want to be able to have one web, not a mobile web and a desktop web, but sort of one web. And the way you do that for some cases is by abstracting out the input device and normalizing up to the intent and to the gesture. So in the case of gesture move, this is synonymous with or analogous to touch start and mouse down. And in fact, it might even be time already to no longer program against mouse down. Even if you're not worried about touch, just start programming against gesture move start, which has sort of the same effect, and now you're getting a broader sort of delivery profile. So you can define when these moves start, when this actually gets fired. There's a couple configuration options. You can set a minimum distance. You don't want a 1 pixel touch or a 1 pixel mouse move to fire this event necessarily. You want to have some a little leeway built in. We've seen this in drag and drop also. A drag event doesn't start the instant you press down on something. You have to show intent by moving some number of pixels before it starts. And that number, in the case of gesture move start, the minimum or the default minimum distance is 10 pixels. If you're working on a different resolution or if you're working with a different density of information, maybe you want to change that. Maybe you want to have a layer that says, if it moves a lot this way or a little bit that way. So that's the type of configuration you can do. You can also do minimum time, which is expressed in pixels per millisecond, I think, which says, I can lazily be moving my mouse around or moving my finger around. And if I contact something and start moving it, if it's lazy, if it doesn't look intentional, if it doesn't look purposeful, then don't fire this event yet. I think the minimum there, I think that defaults to 0. Yeah. In the case of where it's generated by a mouse, you can limit it to a certain button. There's no default for that. And you can prevent the default behavior in all these things. So that's how you start a gesture. Once the gesture's happening, where the touch is moving or the mouse is moving, now the library is firing a gesture move event. It only fires gesture move if it's already detected a start. You don't want to notice all the moves, if it's on a different node or something. You can turn on standalone so that you get them all, but in general, you wouldn't want to start tracking all these movements until you had it initiated. You can put all these things at the whole document level, or you can tailor them to sort of particular routes on the page. And then you probably saw that this was coming next, gesture move end. And so again, the interesting thing here is that instead of having a library called touch, where you do touch start and touch end, we've already normalized it up a level. So now we're just talking about gestures. And so now you can use the mouse or use touch or other devices as we add those in down the road. Any questions on that? Makes sense? So I think I misspoke. Okay, so those are the gestures. And that's really just a normalization of sort of the raw physical input. But now you can start having particular types, and this goes back to that table we looked at of, is it a flick or is it a move or a zoom or this or that. The first one that landed in the library is a flick, where you've sent something on its way. And again, you can configure the minimum distance, the minimum velocity. And in the project I was working on this summer, we had to do that a little bit to sort of get an interaction that felt right. It's nice to do native events in the mobile space. It feels even better to be doing web first stuff, but in order to replicate the polish that a lot of the native events have, it really pays to spend some time tweaking some of these configurations and sort of getting the feedback and the interaction that feels right. An additional configuration option for Flick is the ability to limit it to a certain axis. So this isn't set by default. By default, it just, even if you're a little bit sloppy in your Flick, whichever axis you move further is the one that counts. But if you have a certain thing like swipe to delete, you could say only listen for flicks on that axis. Speaking of swipe to delete. So this is working in YUI. Here we're on Android. Pretty common interaction. You're seeing a cursor because this is the emulator on the desktop, obviously. There you've got a list. We're wiring up those gestures and then doing something nifty with the result. Because it's YUI, it works everywhere out of the box. So here we are on an iPhone. The exact same thing. And the interesting thing now, it's easy to make something work probably on Android and a different touch device. Now we're taking advantage of gesture, and we're doing it with the mouse on the desktop. So that's Safari, and here's Firefox. And so you're adding these new interaction patterns that are more, have emerged on these smartphones, and you're able to bring something like that to the desktop. It's going to take a little while for users to expect that. You wouldn't want that to necessarily be your only way to get some of these tasks accomplished. But for where we are right now, to be able to do that in a couple lines of code is pretty cool. Here it is on the iPad, which is, of course, works the same. Here's how it happens. This example is on YUI, so you can go look at it. I've deleted some of the cruft. It didn't really matter as much. And this is sort of the base interaction, or the base code. So this is a great opportunity to use delegate because there's a lot of potentially, it's a big list. There could be a lot of stuff going on, so you can delegate it, track it once at a higher level. Instead of storing the data, so you want to be able to figure out which direction the swipe was or the flick was, flick swipe, and decide what to do with it. So you want to track, where it started, where it ended, figure out which axis it was, figure out if it met your threshold and what you're going to do based on that. How many people have used set data and get data and clear data on nodes as part of the YUI node libraries? Quite a few. It's a nice way, instead of having to keep everything in your script, to be able to just stash that data right on the node that generated it or right on the node it relates to. So in this case, instead of having the functions keep track of everything, we're just storing that value right there on the node that generated it, and then later on getting that data back out and using it to compare that way. Scroll view is pretty similar, and I think scroll view has a lot of can have a lot of relevance on the desktop also. Carousels are nice sort of for marketing in a way to overload an area. I think scroll views are perhaps even more broadly applicable, a way to put a lot of information into a small piece of real estate. And you'll notice in that, go back and let it run again, you can see that there's a lot of velocity, a lot of acceleration and deceleration that's happening that gives a really responsive feedback. And so that's on a device, and here's the exact same thing, exact same code running in a browser. So again, it's pretty nice to be able to write once, sort of run everywhere. So I think those are the two primary examples that are in YUI today. When we come back next year, I hope there's a lot more from the core team and a lot more sort of throughout the gallery. So please fulfill that. Speaking of that, so what's sort of coming next? Those are sort of the rough building blocks that exist now. You can imagine, from those two sort of simple examples, other things you could do. When I was thinking about sort of touch and thinking about gestures, I remembered Opera's sort of mouse gestures, which I was pretty addicted to for a while. And that was 2001, so coming up on 10 years ago now. And they had a lot of different gestures, and so they all weren't exposed to the web content, but they're still sort of in a browsing context. And I went back to their old docs and grabbed the list, and just with a couple axes and a couple type of events, you can have all these different types of controls. So I'm not saying that we want to reproduce all or any of these necessarily, but I thought it was an interesting example of the type of vocabulary you can create when you have these richer types of input available to you. So some food for thought as we all think about how to bring touch and gesture to all of our projects. And I don't know if it's an arms race or what, but Windows 7, they'll take up to 10 inputs. So that's super multi. And they disclaim in their docs that that they don't guarantee that devices will support that. I mean, most devices maybe give you 4 points, I think, that they're hoping for. But their operating system supports up to 10. So even more, it's hard to think exactly. I mean, everybody has the classic sort of photo example where you're grabbing all these photos, Minority Report or whatever, but 10 seems like a lot, but I guess better to think big. Music, there you go.
I think iPad has 11.
iPad has 11? With that slide. So there's carousels all over Yahoo, all over the web now. Some of them have sort of this hover, slideshows have a lot of this hover event. What would happen if you just changed that arrow to be, a ghosted arrow that showed some notion of motion? And with, a few lines of code, instead of click, click, click to sort of crank around this carousel, you could just send it on its way, whether it's a slideshow or a carousel or sort of any other type of thing like that. So, just with the difference in those two arrows, it completely changes the language of how something like that could work. So, we can come up with a lot of that, and I think designers will too. Another one that you'll get, there's no mouse, so there's no right click on a lot of these touch devices, and so they have sort of press and hold will often bring up some sort of context menu. That seems like something that we could easily bring to the web. So there's a couple ideas. Character gestures. I stumbled across this. I'm not sure we're going to be able to teach all of our users to do this, but it's interesting. So this guy's got a tablet that has an extensible, a trackpad that has an extensible gesture support, including sort of arbitrary shapes and alphabet shapes. And so he's doing this whole interaction, composing this whole document, taking all these notes just through gestures. So that's the configuration for it. You can create all your own. So maybe YUIConf 2012. What? Yeah. I thought that was kind of cool. I guess it works right now. I mean, you can download that and install it, and it'll work if you got a Mac. So, like I said, those are some of the building blocks. Those are some of the core plumbing that exists in YUI. Some of the infrastructure in YUI that makes a lot more plumbing possible. Synthetic events, the addition of touch. Touch is there because it is exposed through the DOM, so that can come in. We're going to have to do a little more work to get some of the other events to start being applicable. But I don't know, I think it's pretty exciting. That's what I have to talk about. I know I'm done early. I'd be interested to hear who else has taken a look at what's in YUI so far. Who else besides Mark and Satyen have been doing touch stuff for YUI? And if you have any questions about what I covered or some of the things I've found in this whirlwind of research that I didn't get a chance to make slides for. So thank you.